Section 3.5 is about solving equations with variables on both sides. So up until this point we have solved equations that only have variables on either the left or the right side, but for these problems we have variables on both sides, the left side and the right side. So when we're solving an equation with variables on both sides, the first thing we need to do is simplify both sides. So whatever you can do to simplify the left side or simplify the right side, all of that should be done first. So to simplify the left side here, we would have to distribute. So we're going to pass out that 2. Remember, distributing is multiplication, so 2 times c is 2c, plus 2 times 1, which is 2, equals, is there any way we can simplify the right side? No, so we're left with 3c minus 5. Once we get here, you want to double check that you can't simplify anything else on the left side or the right side. These two cannot be combined together because one is a c and one is a constant. Same thing here. So we are ready to move some things around. The only difference at this point then is that we have variables on both sides and we want to move one of those variables. Generally, we move the smaller of the two variables so we can work with positive integers and positive coefficients. So which is smaller, the 2c or the 3c? The 2c is smaller, so we're going to take this whole thing and move it over to the right side by undoing it. So we're going to subtract 2c from both sides. So we're left with 2 on the left side. This gives us c, 3c minus 2c. We don't really cross them out. Sorry. 3c minus 2c is 1c, or you can just put c, and then you're left with minus 5. Once you do that, then it looks just like other equations that we've already done. So the c is on the right side right now. So we'll go ahead and move the 5 away from the c by adding 5 to both sides. And we're left with c on the right side, and 2 plus 5 is 7. Now we want to put this in set notation, so we move the c to the left side. C such that c equals 7. Number 2 is very similar, except the right side has a single term instead of 2 terms. So we still do need to get rid of these parentheses. So we want to simplify by distributing. 2 times 5 is 10, minus 2 times 2, or 2 times negative 2h would be negative 4h, equals 4h. Now we've got variables on both sides, so you want to ask yourself which one is the smaller of the two variables. This negative 4h is going to be the smaller one, so we want to undo it by adding 4h to both sides. So we're not going to divide by 4. We want to take this whole term and move it over. So there's no division going on when we're collecting all the variables on one side. You're either adding a term or you're subtracting a term. So this will drop out. We get 10 equals 4h plus 4h, which is 8h. Divide by 8. And then we'll just simplify this. No decimals. So we get h equals, simplify this by dividing both by 2, and we get 5 over 4. You could write it as 1 1/4 if you want. So h such that h equals, you can either write 5/4 or 1 1/4. But we're not going to, technically you could write 1.25, but I tend to suggest that we keep them in fractions. So on your Cornell notes, we can go ahead and fill in the steps here. I have them written down already, but they are here. Solve equations with variables on both sides. Number 1, simplify both sides. That might include distributing and combining like terms. Once you have distributed and combined like terms, then move the smaller variable to the other side by adding or subtracting. And then undo addition or subtraction. These two steps end up being the same in most cases. And then undo multiplication or division. And then go ahead and fill in this example also. 3 times the quantity negative 2 minus 3x equals negative 8x minus 4. So we're going to distribute the 3 to get negative 6, and here to get negative 9x. So we distributed. You can't combine any like terms on the left side or the right side. So then we want to move the smaller variable. So if this is negative 9x and this is negative 8x, the negative 9x is actually smaller. So we add 9x to both sides. These drop out. We get negative 6 equals negative 8x plus 9x is x minus 4. Then we're going to move the 4 over, undoing addition or subtraction in this case. We don't have any multiplication or division. So we're going to add 4 to both sides. Negative 6 plus 4 is negative 2. And these drop out and we get x. So you'll eventually put it in set notation x such that x equals negative 2. And those are your steps for solving equations with variables on both sides. Let's continue to use those. We have some fraction problems here. So when we have fractions, again, the easiest way to deal with fractions is to get rid of them. So what we want to do is multiply through by the common denominator, or in this case there's only one denominator. So we're going to multiply everything by 3. This times 3, this times 3, this times, we'll use this 3 over 1. So 3 times x gives us 3x on the right side. On the left side, 3's cancel, and we're left with just 2x minus 7 times 3, which is 21. Now there are no variables left, and it's a simple, actually simpler than number 1 and number 2 here. So we do see we've got variables on the left side and the right side. There's no way to simplify the left side or the right side, so we can start moving things around. The smaller of the two variables is the 2x, and it's positive, so we're going to subtract it to move it to the other side. Be careful here, though, that 21 is still negative no matter what. Bring that sign down, and 3x minus 2x is x. So we get x such that x equals negative 21. Number 4, very similar, and we've seen a problem like this before where there's only a variable on one side, but we still have a fraction, so we still want to multiply both sides by the denominator, which is again 3. So we multiply the right side by 3 and the left side by 3 over 1. On the right side we get 6n. On the left side, remember, you have to be careful. This 3 is going to cancel with this 3, and nothing ever touches this right here. It stays the same, 4n minus 28. So when you cancel out that denominator, nothing ever gets distributed to this. So here we have 4n minus 28 equals 6n. 4n is the smaller of the two variables, so we want to collect all the variables on one side. So we're going to move that variable by subtracting 4n. Again, be very careful. This is negative 28 equals 6n minus 4n, which is 2n. And then we need to get rid of this 2, so we divide both sides by 2. And we get negative 14 equals n. Put that in set notation, n, such that n equals negative 14. So why don't you, well, let's look at 5 and 6 together. These are special solutions. These are a little bit strange. So as we work through these problems, you can start to see what's strange about them. In the first problem, of course, we need to go ahead and distribute. So we get negative 6. 3 times negative 3x is negative 9x equals, this stays the same, negative 9x minus 4. So we've distributed. We can't combine any like terms on the left or the right. So the next thing we need to do is collect all the x's on one side by moving the smaller x, which is a trick question or a trick skill here because they're both exactly the same size. Oops, I'm sorry. Let's move this up. So we distributed. We're moving the x's together, and they're both exactly 9x and 9x. So we will add 9x to both sides, and what's going to happen? These will drop out, so will these, and you're left with negative 6 equals negative 4. So what this means is that it does not matter what x is in this problem. You could pick any any number to plug in for x here, and they're going to drop out every single time and give you negative 6 equals negative 4, which is, of course, a false statement. Negative 6 does not equal negative 4. So think about it this way. How can I get this to work? There's no way, no variable I could choose to get this to work because the variables will drop out. It will always be false. That means no value. X can't be any value here because it's always going to be false. So the answer is the empty set, or you can write no solution or no solutions. So that's our first special solution when it comes out to be a false statement. When all the variables drop out, we get no solution. What about number 6? This one looks hard. It's really not that challenging. Just take it step by step. On the left side, we need to simplify by distributing, and then we will also have to do another step. So let's begin by distributing. 2 times a is 2a. 2 times negative 8 is negative 16. The plus 7 comes down. Let's look at the right side. We can distribute. 5 times a is 5a. 5 times 2 is 10. Bring the rest of this down. Minus 3a minus 19. Now this problem is truly a test of all of our skills in this section because we do have to distribute on not just one side but both sides. And we are going to have to combine like terms on the left side and combine like terms on the right side. So if we look at the left side, what can we combine that are alike? We've got an a here, and we've got two constants, negative 16 and positive 7. Those can be combined to give us negative 9. So we have 2a minus 9 on the left side. How about on the right side? What can be simplified here? We've got 5a minus 3a, which gives us 2a, and 10 minus 19, which gives us negative 9. Now I don't want you to stop here even if you know what the answer is. For these special solutions, you'll find that every time the variables are going to drop out, and you need to show me that they drop out. So when I go to move the smaller of the two a's, they're both exactly the same size. So we subtract 2a, and we're left with negative 9 equals negative 9. This is a true statement. So that means no matter what I choose for a, no matter what number I plug in for a at the beginning, it will always come out to be true, which means that all the real numbers will work in this problem. Or you can use the real number symbol. It's kind of like the paragraph symbol in English, 2 lines, and then you make your R. So here are your two special solutions. If it comes out to be, if all the variables drop out, it comes out to be false, it's no solution. If all the variables drop out, it comes out to be true, then it's all the reals. Let's go ahead and put that on our Cornell note sheet. Solve equations without one solution, or special solutions, special cases, whatever you want to put there. So I wrote, put a star, when all the variables drop out. Either you get something like this, 2 equals 11, which is false, and you write no solution or the empty set, or 8 equals 8, which is true, so we get all the real numbers, or you use the real number symbol. You don't actually have to say false or true. You can just think that in your mind, which would lead you to these correct answers here. And then go ahead and fill in this equation. 6u plus 5 times the quantity 1 minus u equals u plus 8. So you distribute, and we get positive 5 and negative 5u. The 6u just comes down. Combine your like terms, 6u minus 5u. You can either write 1u or just u plus 5 equals u plus 8. You have to show that the u's drop out. Minus u, they drop out, and we get 5 equals 8. That is false. You can put a line through it to show that it's false, but most importantly, it needs to say no solution there. So those are your special cases. One other thing, some books will say many solutions instead of all the real numbers. So you can use the real number symbol, all the real numbers, or you can write many solutions. All of those would be correct. The only thing, you cannot just stop at true or false. It's got to go on to either no solution or many solutions or all the reals. Okay. And last, we have one final question on the back. It's a consecutive integer problem, but it's a little more challenging than the others. It says 3 times the larger of 3 consecutive even integers. Let's start with this first. So ignore everything else. We know we're setting up 3 consecutive even integers. So remember, if it just said consecutive integers, we'd do x, x plus 1, x plus 2. But it says even integers. So our 3 integers will be x x plus 2 and x plus 4. So once we have our 3 consecutive even integers, now we'll go back and read again. 3 times the largest of the 3 consecutive even integers. Now let's stop. Maybe we should label these small, medium, and large. Okay? Small, medium, large. It says 3 times the largest. That means 3 times the largest number, which is x plus 4. Now we can't just write 3 times x plus 4 because then we'd only be multiplying the x times 3. We need to multiply this entire integer, so we need parentheses around it. 3 times the largest integer is 38 more than. Now, as soon as we see that more than, I need to start writing backwards. 38 more than twice the smallest. Twice the smallest integer, which is x. Now, you could put the x in parentheses, but you don't need the parentheses because it's just a single term. So let's read this again. 3 times the largest. 3 times the largest is equals 38 more than twice the smallest integer. Find the 3 consecutive even integers. So then we just need to go ahead and solve this. Distribute on the left side. We get 3x plus 12 equals 2x plus 38. Collect your variables on one side. This is the smaller one, so we're going to move that over by subtracting 2x. We get x plus 12 equals 38. And we'll move the 12 over by subtracting 12. We get x equals 26. Now let's check these. If this one is 26, that makes this one 28 and this one 30. And let's go back and plug this back in. 3 times the largest, which is 30, is 38 more than twice the smallest, which is 26. So 3 times 30 gives us 90. 2 times 26 is 52. It's 38. And we do get 90 equals 90. So it does, 90. So it does work. And then don't forget it's a word problem, so we have to write the answer. The integers are 26, 28, and 30.